So as two galaxies collide with each other, there is this period of intense starburst, and that's what we call starburster galaxies. That doesn't last forever. It's really just when the when the gas and dust of each galaxy merges together, it's going to those shock waves cause incredible star formation to take place. All right, so this is a very famous one. This is an example. On the left-hand side, this is an actual picture of it's very famous, called the antenna galaxies, because there's actually two galaxies that are merging. And notice on the right hand side here, this is actually a computer simulation of what would happen if you have these two galaxies coming together. And they basically in the supercomputers they will program them to approach each other at different angles and use different masses and things like that. It's just interesting that you see this picture of these two spiral galaxies coming together, and you get these long arms coming from it, and then here's an actual photograph of from the real world, from the real universe, of this kind of thing taking place. So it's always good when your simulations are borne out in reality. All right, you feel that you're onto something. All right, so and we do use this simulation, especially using supercomputers and programming. I mean, there's tremendous amounts, terabytes and terabytes and terabytes of data that is computationally calculated to get these things to take place. I mean, remember when these galaxies collide, it takes millions and millions of years for that to happen, and in a supercomputer you can do that in a matter of minutes, and work out what the results are going to be, or at least what the results would be, if under certain conditions. And so we look at all these different scenarios. Let's see. So now in this section we're going to look at galactic formation and evolution. So this, as it says here, galaxies are believed to have formed from mergers, and very similar to remember, like how stars are born. So stars come. This is going back several chapters, from huge clouds of it's just on a much bigger scale, right? For stars, you have several parsecs, of across these clouds that will eventually start to collapse. You remember that the collapse is usually triggered by some other event, some external event to the cloud, and then as it collapses, it begins to fragment, and then each of those fragments will eventually have be a star forming region. All right, so for galactic formation, we think it started with, you got to start with the Big Bang, of course, when all the hydrogen and helium were originally formed. Roughly 25% of the universe, of the creation of the universe, went into forming all the hydrogen. All the helium in the universe, and then about 75% was the hydrogen, right? That's why there's so much more hydrogen out there in the universe. Anyhow, so you have this, and remember, the universe was, I know we're not quite into chapter 26 yet, this is more the subject of chapter 26, but they're really linked, right? So you have all this hydrogen and helium out there in a very relatively small volume, much smaller than it is. The universe was much smaller than it is today. So you're talking about a time about 13 billion years ago, just shortly after the formation of the universe. You get, or the creation of the universe, you get these clouds that will basically fragment, and then they're merging, and during the mergers of the smaller galaxies, you get clusters, and then of course the clusters themselves, which are gravitationally bound, will merge with other clusters, as we're going to see, to form even bigger clusters. We're going to actually get into what are called clusters of clusters, and they're actually better known as a supercluster. All right, so this is an image called the Hubble Deep Field. So using the Hubble telescope, astronomers thought about this long ago. With the Hubble Space Telescope, just aim it at a portion of the sky that just appears to be completely black, and just aim it at that particular location, and just let the photons in and see what images occur. What images will form, and so you leave it exposed. You leave the telescope exposed to that same region for long enough time, you get what's called the Hubble Deep Field. And this deep field shows enormous numbers of galaxies. And just to let you know, by the way, there's another image that was taken several years after this, called the Hubble Ultra Deep Field. Just a little aside. Which also shows, again, more, just about every speck you see is a galaxy. So there are tremendous amounts of galaxies out there in the universe. Our Milky Way is just one of them, and then our Milky Way is part of the local group, which is not really a cluster of galaxies, but it's near some other clusters, and in fact, clusters will, as we're going to find out in just a moment, the clusters will form what are called superclusters. All right, so this is looking at star formation over time, right? Remember, when we look out into the universe, so looking at these different galaxies is really a look back in time, because it takes the speed of light is just a finite number. Of course, it's 3 times 10 to the 8th meters per second, or 3 times 10 to the 5th kilometers per second. So the further a galaxy is away from us, the further back in time that we're looking. All right. So when we look, we say, okay, well, when is the most star formation taking place? When we look and we say, on average, when are galaxies forming the most stars? And you can see that there is a time about 10 billion years ago where the amount of the star formation was at a peak. And so this is generally we talk about this instead of talking about it in the past, and which is fine, but we like to in astronomy we like to talk about the red shifts. Okay, so when the red shifts were about around 2, so it's basically between 1 and 3. So when you get a redshift of about between 1 and 3, you're getting the most stars forming. And of course, remember, there are redshifts that are like 7, and these are things that happen very early in the universe. And of course, more recently, you get redshifts, 0.25 and things like that. So those are relatively close, not really close by, but relatively recent in the past, just maybe a few billion years ago, whereas redshifts of 2 to 3, you're talking about 10 billion, more than 10 billion years ago. All right, so so this is just showing some more. These are actual photographs of more galaxies merging, just in different regions of the sky. So we know that in fact the Milky Way has actually been growing, because there's evidence of smaller galaxies being absorbed by the Milky Way. In fact, they're just not really showing it here, but if you take the Milky Way, of course, you got these two relatively, they're not really that large, but the two irregular galaxies, the small and large clouds of Magellan, we think eventually will merge with the Milky Way and make it a little bit bigger. If you have a spiral galaxy and there's a galactic collision with a smaller galaxy, we think that will form just basically a larger spiral galaxy. Okay, so and then and I had already mentioned this, if you have two spirals that are about the same size and they merge, and so again, we do this with computer simulations, and then we actually go and look to see if there's any evidence of this. So here are two spirals that are about the same size, and we think that is what forms elliptical galaxies. And so when they collide, of course, remember, if you keep in mind what's going on in an elliptical galaxy, there are really old stars, 10 billion year old stars plus, and virtually no gas and dust. So there's no new star formation. In other words, these two merge and they undergo a period of intense star formation. That's the starburster galaxies. And then you don't have any more gas and dust to form new stars. And so what's left is an elliptical galaxy. All right, so and then of course you have spiral galaxies, and smaller galaxies will form a larger spiral galaxy. So that is, this hasn't been completely accepted by everybody in the astronomical community, of course, but there more and more evidence seems to point to this particular direction. All right, so that two relatively two spiral galaxies that are about the same size will eventually form, if they merge, will form elliptical galaxies, and then spiral galaxy and a smaller galaxy, like what we consider a dwarf galaxy, will make a larger spiral. All right, so here's some evidence that comes from what's called the Sloan Digital Sky Survey. So it's the SDSS is how it's known in the astronomical community, and this is a relatively inexpensive program. So this has been tremendously beneficial, and so what's going on? The reason that this is so beneficial is we can devote a lot more time to this relatively, compared to most modern telescopes, it's a relatively small telescope in New Mexico, and so obviously it can only look in the northern hemisphere. But we can get incredible details, and so it's basically just looking at different patches of the sky night after night after night. As long as it's clear, and in New Mexico it's usually pretty clear, and so we're getting incredible amounts of information from this relatively inexpensive telescope. So that's what's called the Sloan the Sloan Digital Sky Survey. And this is ongoing. This is still going on. People get